Welcome. In this video, we are covering everything you need to pass the Red Hat Certified System Administrator exam, the RHCSA 200. We're going through Linux file systems, user management, permissions, SE Linux, networking, storage, containers with Podman, and troubleshooting. This is your complete study guide. Let's get into it. Let's start with the exam itself. What is the RHCSA? The Red Hat Certified System Administrator is a performance-based exam run by Red Hat. There are no multiple-choice questions. You sit down in front of a live RHEL9 system and complete a series of administrator tasks. Either the system is in the correct state at the end of the exam, or it isn't. Click the exam test's 7 domains. Essential tools at 20%, file management, text processing, the shell. Storage and LVM at 20%, the biggest technical domain. Security and SE Linux at 15%. Containers with Podman at 13%. This was added in the RHEL9 exam, and candidates often underestimate it. Users and groups at 12%. Services at 10%. And networking at 10%. Look at the exam details. Exam code EX200. You get 3 hours. The passing score is 210 out of 300. That is 70%. The exam environment is RHEL9, running in a live virtual machine. You have access to man, help, and all the standard system documentation. The exam tests speed and muscle memory as much as knowledge. 3 hours sounds like a lot, until you are under pressure. Before you can administer a Linux system, you need to own the file system layout. This diagram shows the Standard File System Hierarchy Standard, the FHS, as implemented on RHEL9. Everything starts at /, the root. There are no drive letters. Everything hangs off a single tree. Beat, the directories you will be in constantly as an admin, etc. This is where all configuration lives. SSHD_config, FSTAB, passwd, hosts, it is all in, etc. var is variable data, logs, print spools, mail, package caches. /home is where user directories live. /root is the root user's home directory, separate from /home. The virtual file systems. Proc is a kernel-provided virtual file system. It doesn't exist on disk. Reading proc CPU info or /proc/mim info is reading kernel data structures directly. /sys is similar. It exposes hardware and driver information. /dev contains device files. /dev SDA is your first disk. /dev/null discards everything written to it. Click the key files table at the bottom. Commit these paths to memory. You will need them constantly in the exam. /etc. /passwd is the user database. /etc. /shadow stores hashed passwords. /etc. /fstab controls what gets mounted at boot. /var/log /secure contains all authentication events, every sudo, every SSH login, every su. The Essential Tools domain is 20% of the exam, and it underlies everything else. These commands are the vocabulary of Linux administration. Starting with file management. LSLA, long format, show hidden files, human readable sizes. Learn to read the output instantly. Stat shows you inode number, file type, size, and all 3 timestamps. Access, modify, change. Find is one of the most powerful commands on the system. Find /name *conf. Type F2 >dev/null. Locate every config file on the system, suppressing permission errors. The SUID find perm 4000 locates all set user ID binaries. You need this for security audits. Text processing is heavily tested. grep -rn pattern, etc. Recursive search with line numbers. grep versus #hash, etc. SSHD _config strips comment lines, showing only active configuration. sedi makes in-place edits with no need to open a text editor. Mastering sed means you can automate config changes in scripts. awk bunmaf $3 greater than equals 1000, print $1, /passwd, print every regular user account. The field separator is : and we filter on UID being 1000 or higher. Click Archives. tar flags are tested every exam. C for create, X for extract, Z for gzip, V for verbose, F for file. Think, create extract, zip verbose, file, tar, -czbf backup.tar, gz text etc., compress dust etc. into a tarball. Tar, -xzvf, extract it. Click IO redirection, greater than overwrites, greater than appends, 2, greater than captures stderr, and greater than captures both. The 2 greater than /dev/null pattern is everywhere. It silences permission denied errors from find and other commands. The here document cat, less than EOF greater than / etc., etc., lets you write multi-line content to a file inline in a script without a text editor. Essential for automation. Users and groups is 12% of the exam, and every RHCSA exam includes at least one user management task. Know these commands cold. User_add Alice creates a user with system defaults. But on the exam you will usually need options. -m to create the home directory, -s/bin/bash to set the login shell, -u1500 to assign a specific UID, -gwheel devs to add supplemental groups. Know the difference between -g and -g. Lowercase -g sets the primary group. Uppercase -g sets supplemental groups. Get them backwards, and you will fail the task. Beat user mod -ag is the most common modification command. A flag means append. It adds the user to the group without removing them from existing groups. Forgetting the A replaces all supplemental groups with a single new one, a common mistake. User mod -l locks an account. User mod -e sets an expiry date. Beat password aging is consistently tested. Change M90W14 Alice set maximum password age to 90 days. Warn 14 days before expiry. Change -l Alice shows the current aging configuration. PassWD-N7 sets the minimum number of days between password changes. Click the 3 password database files, /etc/passwd, one line per user, world readable, contains username, UID, GID, home directory and shell, but not the actual password, just an X placeholder, /etc/shadow, the actual password hashes, readable only by root, /etc/group, group definitions and membership lists. Click sudo configuration. The sudo is the safe editor for /etc/sudoers. It validates the syntax before saving, preventing you from locking yourself out. For production systems, drop individual files into /etc/sudoers.d, /one file per user or role. Always set permissions to 440 on those files. Next. Permissions are the foundation of Linux security. Let's build up from first principles. The diagram shows the standard permission string. The first character is the file type, dash for a regular file, D for a directory, L for a symbolic link. Then 3 groups of 3 bits, owner, group, and other. Each group has read, write, and execute, values 4, 2, and 1. Chmod 755 script.sh. Owner gets RWX7, group gets RX5, others get RX5. Chmod U+X, G-W file, symbolic notation, add execute for user, remove write for group. Beat, special permission bits, these catch candidates off guard. SUID, on an executable file. The process runs with the owner's UID, not the caller's UID. That is how PassWD lets regular users modify /etc/shadow. It is SUID root. Set it with chmod U+S, or octal 4755. SGID on a directory causes new files created inside to inherit the directory's group, essential for shared project directories. Set with chmod G+S, or 2775. Sticky bit on a directory prevents users from deleting files they don't own. The classic use is /tmp, set with chmod +T or 1777. Beat umask inverts. A umask of 022 means new files get 644, and new directories get 755. The calculation, file default 666 minus umask 022 equals 644. Directory default 777 minus umask 022 equals 755. Click ACL's access control lists, give you per user and per group permissions beyond the standard owner/group/other model. Get FACL reads them, setfacl-m sets them. When you configure a shared directory, set a default ACL with setfacl-d. This gets automatically applied to every new file and subdirectory created inside. Without the default ACL, new files revert to standard permissions, and your colleagues lose access. Click chatter +I makes a file immutable. Even root cannot delete or modify it until the attribute is removed. LSATTR shows attributes. Know the +A append-only attribute for log files that should never be overwritten. Next. SE Linux is 15% of the exam, and it is the topic that causes the most unnecessary failures. Candidates disable it because they don't understand it. The exam will check, do not disable SE Linux. Look at the architecture diagram. SE Linux adds a mandatory access control layer on top of standard Linux permissions. Even if file permissions allow an operation, SE Linux can still deny it. The decision is made by the AVC Access Vector Cache. which checks the process type against the object type against the policy rules. If the policy says no, the operation is denied, and the denial is logged in /var/log/audit/audit.log. There are 3 modes. Enforcing the normal production mode. Denials are logged and enforced. Permissive denials are logged but not enforced. This is your debugging mode. Switch to permissive to confirm SE Linux is causing an issue, then fix the context or Boolean, rather than leaving it permissive. Disabled SE Linux is completely off. This requires a file system relabel on re-enable. Get enforced tells you the current mode in one word. Status gives the full picture. Set enforce 0 switches to permissive temporarily. It does not survive a reboot. The persistent setting is clinux equals enforcing in /etc/clinux/config. Beat context are the labels. Every file, process, port, and network socket has a context. LSZ shows file contexts. PSAUXZ shows process contexts. The context format is user role type level. And for the RHCSA, 99% of issues come down to the type field. The most common Linux exam task. You put a web file somewhere Apache can't read because the type is wrong. chcon -thttpd_sys_content_t/srv/web/index.html applies the right type, but it is not persistent. The correct workflow for production is cmanage f-context to add the rule to the policy, then restore con-rv to apply it. If you use chcon without cmanage, a restore con from a script or the next auto relabel will revert your contexts. Click troubleshooting. When something is denied, search mavcts recent shows recent denial messages. Pipe it through audit2y to get a human-readable explanation. Audit2 allow -mypolicy generates a custom policy module from the denials and cmodule-imypolicy. pp installs it. The common context types table, httpd_sys_content_t for web content, ssh_home_t for .ssh directories. Memorize the top 5. Click. Booleans are on/off switches in the policy. No need to write custom policy modules for common scenarios. getCbool, grep httpd, list all Apache-related booleans. setCbool, phttpd_can_network_connect on, the P flag makes it persistent. Forgetting -P means it resets on reboot. It is on every exam that includes SE Linux. Networking is 10% of the exam. The tasks are very specific. Configure a static IP, set a hostname, verify connectivity. Get comfortable with NMCLI. NMCLI connection show lists all connections. NMCLI device status shows the physical interfaces and what's connected to them. Beat, the static IP creation command is long, but follows a clear pattern. NMCLI connection add starts it, then type Ethernet, con name for the connection label, if name for the actual network interface, IPv4.method manual to switch from DHCP to static, IPv4.addresses with CIDR notation, IPv4.gateway, IPv4.DNS, and autoconnect yes. Then bring it up with NMCLI connection up, static ETH0. After modifying an existing connection with NMCLI connection modify, you need to bring it down and up again for changes to take effect, or run NMCLI connection reload. Beat hostname, ctl set hostname server1.example.com. Short hostname is everything before the first dot. FQDN is the full name. Update /etc//hosts to resolve the hostname locally when there is no DNS. 127.0.0.1 server1.example.com server1. Click the diagnostic toolkit. IPADDR show replaces ifconfig. Use it. IP route show shows the routing table. SSTULNP is your port and service tool. TCP, UDP, listening, with process name and PID. It replaces netstat. Dig is the definitive DNS lookup tool. Click the key config files, /etc//hosts for static resolution. /etc//resolve.conf is managed by Network Manager, don't edit it directly, configure DNS through NMCLI. /etc//nsswitch.conf controls the order of resolution, whether hosts is checked before DNS. Ext. Firewalled is the default firewall on RHEL9. It sits on top of the NF tables kernel framework and uses a zone model. Look at the diagram. A zone is a trust level assigned to a network interface. The public zone is the default, suitable for interfaces facing untrusted networks. Internal is for trusted internal networks. Trusted allows all traffic. Drop silently drops everything. Every interface lives in exactly one zone at a time. The two most important flags to know: permanent and reload. A firewall change without permanent is runtime only. It takes effect immediately, but is lost on the next firewall CMD reload or system reboot. With permanent, the change is written to the configuration file but does not take effect until you run firewall cmd reload. So the standard workflow for any permanent change is, add the rule with permanent, then firewall cmd reload. Beat services versus ports. If the service is in firewall's built-in service list, use add service equals HTTP. It's readable and doesn't require you to remember that HTTP is port 80. For custom ports or services not in the list, use add port equals 8080 TCP. Firewall CMD list. All shows everything. Active zone, interfaces, services, ports, and rich rules, all in one view. Click Rich Rules give you fine-grained control. Allow only a specific source subnet to SSH, block a specific IP, rate limit connections. The syntax is verbose but consistent. Rule family equals IPv4 inches, source address equals, service name equals, except. Click Masquerading as NAT. It hides a private network behind the firewall's IP. Enable it once with add masquerade, permanent. Port forwarding redirects traffic coming in on one port to a different port or host. Classic use case is forwarding port 80 to an app running on port 8080. Next. RHEL uses DNF as its package manager, backed by RPM. You need both for the exam. DNF Search Engine X searches available packages by name and description. DNF provides /usr/bin/python3 answers the question, which package gives me this file? Extremely useful when you see a missing binary. DNF install httpd mod_ssly installs multiple packages in one command. Vi says yes to all prompts, essential in scripts. Beat DNF history is a full transaction log. Every install, update, and remove is recorded with a transaction ID. DNF history undo 12 rolls back transaction number 12, removing everything that was installed in that transaction. This is a powerful safety net. DNF group manages environment groups, predefined collections of packages. DNF group install development tools, installs GCC, make, git, and a dozen other build tools in one command. Module streams are a RHEL 8 and 9 feature that lets you maintain multiple versions of the same software in the AppStream repository, 8 Philippine pesos and 10 centavos, 8 Philippine pesos and 20 centavos, and 8 Philippine pesos and 30 centavos simultaneously. DNF module list PHP shows all available streams and which one is active. DNF module enable PHP 8.2 switches the active version. Use streams to run the exact version your application requires. Click RPM is the low-level package tool. RPM QA lists every installed package. RPM QF/etc. /httpd/conf/httpd.conf answers. Which RPM owns this file? Critical for auditing. RPM verify HTTPD checks file integrity against the package's manifest. It reports if any installed files have been modified since installation. And RPM2CPIO package.rpmcpio-idmv extracts files from an RPM without installing it. Useful for recovering a single config file. Click repository files live in /etc/yum.repos.d/. Each .repo file defines a repository with a base URL, enabled flag, and GPG check flag. DNF config manager, add repo URL, automates adding a new repository. Next. Systemd is PID1 on every modern RHEL system. It manages services, mounts, timers, sockets, and the boot sequence. Look at the state diagram. A unit starts as inactive. Systemctl start triggers the activating state. If it succeeds, it becomes active. If it crashes or the service process exits with an error, it goes to failed. From active, systemctl stop transitions through deactivating back to inactive. Beat the 6 essential systemctl verbs: start, stop, restart, reload, enable, and status. Restart is stop, then start, brief downtime. Reload sends the process a signal to reread its configuration without restarting. Zero downtime, but not all services support it. Enable creates the symlink that causes the service to start at boot. It does not start it immediately. Systemctl enable. Now HTTPD enables and starts in a single command. Use this one every time. Systemctl mask is stronger than disable. A masked service cannot be started by anything, not manually, not as a dependency of another service. Use it to permanently prevent a service from running. Click creating a custom service unit. The file goes in /etc/systemd/system/. This directory takes priority over the system-provided units in usr/lib/systemd/system/. Look at the unit file shown. The unit section has after equals network.target This ensures the service starts after the network is up. The service section specifies the user, working directory, exec start command, restart policy, resource limits, limit no file, memory max, CPU quota. The install section's wanted by equals multi-user.target hooks it into the standard boot sequence. After creating or editing any unit file, always run systemctl daemon reload first. Without it, systemd doesn't know the file was changed. Click targets are systemd's equivalent of run levels. Multi-user.target is the standard headless server mode, no GUI. Graphical.target adds the display manager. Rescue.target is single-user mode. Systemctl set-default multi-user.target sets the boot target persistently. Systemctl isolate rescue.target switches the running system immediately. Ext. Systemd's journal is the centralized log store on RHEL9. Every service's std out and stderr, every kernel message, every boot event, all in one place, queryable with journalctl. Journalctlu, HTTPD, all logs for the HTTPD service. Journalctlu, HTTPDF, follow the logs live as they come in. Journalctl-per, only error level messages and above. Journalctlb, only logs from the current boot. Journalctl-b-1, logs from the previous boot, invaluable when a system crashed and rebooted and you need to know what happened. Journalctl since 1 hour ago, time filtering. Combine these filters, journalctlu, httpdper, since today. Beat by default on RHEL9, the journal is stored in /run/log/journals, which is a TMPFS. It does not survive reboots. To make it persistent, create the directory /var/log/journals/ and restart systemd-journaled. Then set storage equals persistent in /etc/systemd/journal.conf to make it explicit. Journalctl vacuum size equals 500 M and vacuum time equals 30D. Trim old journal data. Click RHCSA is the traditional text-based logging daemon that runs alongside the journal on RHEL9. Key log files /var/log/messages for general system events, /var/log/secure for authentication and authorization, every sudo, every SSH connection. Know where to look for evidence when troubleshooting a security event. Click logrotate manages log file rotation. Configuration in /etc/logrotate.d/1 file per application. The directives, weekly or daily trigger, rotate 4, keeps 4 rotations, compress gzips old logs, postrotate runs a command after rotation, typically reloading the service to open a new log file. Ext. Process management covers monitoring, controlling, and prioritizing processes on a live system. PSO gives you the full process table, all processes, all users, with CPU and memory percentages. PSEO PID, PPID, CMD, %CPU, %mem, sort, equals, %CPU, head -20, custom format, sorted by CPU, top 20. PS tree, P shows the parent-child hierarchy with PIDs, useful for understanding how processes relate to each other. LSOFI, 80, answers, what process is listening on port 80? Same information as SSTLNP grep, 80, but through a different angle. LSOFP 1234 shows every file handle held open by a specific process. Beat signals, kill PID sends sigterm, a polite request to shut down. The process may catch this signal and clean up. Kill -9 PID sends SIGKILL, the kernel forcibly terminates the process with no chance to clean up. Always try sigterm first. Kill -1 PID sends SIGHUP. Many daemons treat this as a reload signal. Kill on Yingx sends sigterm to every process named Yingx. Jobs and background's a command. Control+Z suspends the foreground job. Jobs lists all background and suspended jobs. FG%1 brings job 1 back to the foreground. NoHup command and makes a background command immune to the SIGHUP signal sent when you log out. Use it when you need a long-running task to survive your session ending. Click Nice and Renice control CPU scheduling priority. Nice values range from -20, highest priority, more CPU, to +19, lowest priority, yields to everything. Regular users can only increase niceness, lower priority. Root can decrease it, higher priority. Renice, nice N5, P1234 repriorities, a running process. In top, the NI column shows the current nice value. Click VMSTAT15. 5 snapshots of CPU, memory, and I/O every 1 second. The SI and SO columns show swap in and swap out. If these are non-zero, the system is memory starved. Free-H for a quick memory overview. Ext. Storage is 20% of the RHCSA exam and is consistently one of the most technically detailed domains. LVM, Logical Volume Manager, is the core topic. Understand every layer. Look at the architecture diagram. At the bottom are physical disks, /dev SDB, /dev SDC. You create physical volumes from partitions or whole disks with PV create. Physical volumes are then pooled into a volume group. Think of this as a storage pool. From the volume group, you carve out logical volumes of any size you want. And logical volumes get formatted with a file system and mounted. The critical advantage of LVM: you can extend a logical volume while it is mounted and in use. No downtime. Just extend the LV, then grow the file system. Be the 4-step LVM workflow. Step 1. PV create, dev SDB1, dev SDC1. Initialize the physical volumes. Verify with PVS. Step 2. VG create VG_data /dev SDB1 /dev SDC1. Create the volume group from those PVs. Verify with VGS. Step 3. LV create nesh NLV_web -L100 GVG_data. Carve out a 100 GB logical volume. Or use -L 50% free to take half of the remaining space. Verify with LVS. Step 4. mkfs.xfs /dev VG_data /LV_web. Format it. Then mount it. Beat extending. When you need more space, LV extend -L plus 20G /dev VG_data LV_web. Add 20 gigs to the logical volume. But the file system doesn't know yet. For XFS, XFS_growths var www. Run this against the mount point. XFS growth is online. For ext4, resize 2fs /dev VG_data LV_web. Run this against the device path. Adding capacity when the VG is full. Create a new PV from another disk. And VG extend VG_data /dev SDD1. The new space is immediately available to any LV in the group. Click partitioning parted /dev SDBMK label GPT, then parted /dev SDBMK part primary 0% 50%. For interactive MBR partitioning, fdisk /dev /SDBN for new, P for primary, W to write. After any partitioning change, part probe /dev SDB tells the running kernel about the new partition table without requiring a reboot. Ext. Creating a file system and mounting it manually is temporary. It does not survive a reboot. Making it permanent requires an entry in /etc/fstab. MKFS formats a device. MKFS.xfs for XFS, the default on RHEL9. MKFS.x4 for ext4. MKFS VFAT for FAT32 on removable media. After formatting, mkdirp/mount point and mount /dev VG_data /LV_web /var /www. Beat /etc/fstab, the persistent mount configuration. The 6 fields: device, mount point, file system type, mount options, dump flag, pass number. For the device field, always use UUID, never the device name like /dev SDB1. Device names change when disks are added or removed. UUIDs never change. blkid/dev /VG_data /LV_web gives you the UUID. The pass number: 1 for the root file system, 2 for all others, 0 to skip file system check entirely. The most important test, after editing FSTAB mount A, it attempts to mount everything in FSTAB that isn't already mounted. If there is a syntax error or a missing device, you will see the error now, instead of discovering it during an emergency reboot. A bad FSTAB entry can prevent the system from booting. Beat swap, fallocate, -L2G/swap file creates a swap file. chmod 600/swap file sets permissions. mkswap, swap file formats it. swapin swap file activates it. Add it to FSTAB, with swap as the file system type, and SW as the options. Click Common FSTAB Mount Options to know. Defaults expands to RW, SUID, Dev, Exec, Auto, Nowser, Async. No exec prevents executing binaries from that file system. Use it on CMP for security. _netdev, tells the boot process to wait for the network before mounting, required for NFS and RHCSA. No fail means a failed mount does not abort the boot process. Use it for removable media or optional network shares. Next, both cron and systemd timers appear in the RHCSA. Know both. crontab-E opens the current user's cron tab in the default editor. The 5 time fields: minute, hour, day of month, day of week. Asterisk means every. 02 asterisk 9 asterisk at minute 0 of hour 2 every day, that is 2 a.m. daily. Asterisk /15 asterisk timed 9th asterisk every 15 minutes. 09 asterisk 1 to 9 a.m. every Monday. Beat system-wide cron jobs go in /etc/cron.d /as drop-in files or in /etc/crontab. These files have an extra field for the user. The command runs as since /etc/crontab can run commands as any user, not just the owner. /etc/cron.daily /etc/cron.weekly drop a script in those directories, and it runs on that schedule. No crontab entry needed. Always redirect output in cron jobs greater than /var /log /backup.log 2 greater than and 1. Without this, cron mails output to the user, which usually means it silently disappears if no mail service is configured. Click systemd timers are the modern alternative. A timer unit pairs with a service unit. The timer section's on calendar specifies when to run ****, 2 hours 0 minutes and 0 seconds is daily at 2 a.m. Persistent equals true is critical. If the system was off when the timer was supposed to fire, it will fire immediately on next boot, catching up on missed runs. System CTL list timers all shows every timer, its last trigger, and its next scheduled run. Click when to use which. Cron is simpler for basic scheduling. Systemd timers give you better logging through the journal, resource control, dependency management, and persistent equals true catch-up behavior. Next, SSH configuration and key-based authentication are standard RHCSA exam tasks. SSH keygen, TED 25519, generate an ED 25519 key pair. ED 25519 is the modern recommended algorithm, smaller and faster than RSA. The private key stays on your client at ~/.sshid_ED 25519. The public key goes to the server. SSH copy-ID Alice at server 1 is the easy path. It copies your public key into the correct location on the remote server with the correct permissions. Manually, append the public key to ~.ssh authorized_keys with permission 700 on ~.ssh and 600 on authorized_keys. SSH will silently ignore authorized_keys if the permissions are too open. This is the most common reason key auth fails after manual setup. Beat the ~.ssh config file lets you define connection aliases. Instead of SSHI ~.ssh custom_key, native P2222 Alice at 192.168.1.10, you write a host server 1 block and just type SSH server 1. Essential for working efficiently with multiple servers. Beat /etc. SSH SSHD_config, the server configuration. Non-negotiable settings. Permit root login, no. Never allow direct root login. Password authentication, no. Force key only login once you have keys deployed. Max auth trees 3. Limit brute force attempts. Allow users or allow groups, whitelist who can log in via SSH. Everyone else is denied regardless of their password. Click RSYNCAVZ-delete /local/Alice at server 1. Skeptical smiley face remote / is the go-to backup sync command. A is archive mode. Recursive. Preserves permissions, ownership, timestamps, and symlinks. -Z compresses in transit. Delete removes files from the destination that no longer exist on the source. -N for dry run before committing. Ext. Containers with Podman is 13% of the RHCSA, added in the RHEL 9 exam version. Do not skip this domain. Look at the comparison diagram. Docker uses a daemon, a background root process called Docker that all container operations go through. Podman is daemonless. The podman command directly forks container processes via conman and runc. No daemon means no single point of failure, and no root daemon running all the time. Beat the Podman CLI is intentionally Docker compatible. Podman run, Podman images, Podman build, Podman push. Same syntax as Docker. If you know Docker, you know Podman. The key difference is rootless containers. Podman can run containers as a regular user with no root privileges. Rootless containers cannot bind to ports below 1024 by default, and storage goes into the user's home directory at ~/.local/share/containers. The Z volume mount flag is RHEL specific and important. When you bind mount a host directory, native v/srv html skeptical smiley face usr share nginx html/nginx may block the container from reading those files because the host path has a different context than the container expects. Adding Z relabels the mounted content with the correct C/Linux context for container access. This is a common exam gotcha. Click rootless podman as a systemd service. This is frequently tested. The workflow. With your container running, generate a systemd unit file with podman, generate systemd-new, name web, >config/systemd/user/container-web.service. Then systemctl, user daemon reload, and systemctl, user enable, now container-web.service. The user flag keeps everything in user space, no root required. The critical last step, login kcl, enable linger alice. Without this, systemd stops all user services when the user logs out. Lingering allows user services to persist, starting at boot and surviving logouts. This step is on every RHCSA exam that includes podman. Click pods in podman work like Kubernetes pods, multiple containers sharing a network namespace. Podman pod create, name my app pod, -p8080-80, and then run containers into it with pod, my app pod. All containers in the pod share the same IP and localhost. Next, understanding the boot sequence lets you fix problems at every stage. The RHEL9 boot chain, UEFI BIOS, initializes hardware and hands off to grub2, which loads the Linux kernel and initerd from /boot. The kernel mounts the initial RAM disk, sets up hardware, then hands control to PID1, systemd. Systemd brings up sysinit.target, then network.target, then multi-user.target, and finally graphical.target if configured. Each target is a collection of services that must be running before the next target activates. Beat, resetting the root password is a standard RHCSA exam task. The steps: reboot, press E at the grub menu to edit the boot entry. Find the line starting with Linux. Navigate to the end of that line and append rdbreak. Press Ctrl+X to boot. You land in an initramps shell before the real root file system is mounted. Remount the sysroot read-write. Mount, remount, rw sysroot. Croot into it. Croot/sysroot. Now run passwd root to set the new password. Then, and this is where people fail, touch/auto relabel. Without this, SE-Linux will see the new /etc/shadow has the wrong context and deny logins. The file triggers a full file system relabel on the next boot. Exit twice to reboot. Click grub2 management. The configuration template lives in /etc/default/grub. Set the timeout, default entry, and kernel command line options there. After editing it, regenerate the actual config with grub2 mkconfig o/boot/grub2/grub.cfg for BIOS systems, or the EFI path for UEFI systems. Know which path your exam environment uses, ls/boot/EFI to check. Click systemd analyze blame, lists every service unit in order of how long it took to start, your first tool for diagnosing a slow boot. Systemd analyze critical chain shows the dependency chain that was on the critical path, the sequence of services that the boot had to wait for. Next, the exam occasionally requires you to write a shell script. More importantly, reading and understanding scripts is essential for troubleshooting. The shebang line #bin/bash declares the interpreter. The next line is essential for production scripts. Set, EUO pipefail. -E exits immediately if any command returns a non-zero exit code. U treats unset variables as an error, prevents the classic bug where an unset variable causes rm-rf$dir to become rm-rf. O pipefail means a pipeline fails if any command in it fails, not just the last one. Add this to every script you write. Positional parameters and validation. $1, usage, $0 username. If $1 is unset or empty, the script immediately exits with an error message. Check argument count with $#hashname2. Check if running as root with $euid ni0. The while ifs equals read nar user pass loop reads a colon-delimited CSV file line by line, the same structure as etc/passwd. This is the standard safe pattern for processing structured text files in bash. Beat functions make scripts maintainable. The log function shown uses TA to write to both std_out and a log file simultaneously. The die function writes to std_err with greater than and to and exits. The trap cleanup exit line registers a function to run whenever the script exits for any reason, even on error. Use it for cleanup tasks. Click File Test Operators. The exam uses these. -F tests for a regular file. -D for a directory. -X for executable permission. -S for a non-empty file. The -F/etc. /httpd/conf/httpd.conf pattern is how you check whether a service is installed before trying to configure it. Next, let's talk strategy and the commands you need in your muscle memory. The one-liners block is your quick reference for the most common exam tasks. Walk through the user creation block. Create the user with the right options in one command. Pipe the password straight to chpasswd. Set password aging with change, and drop the sudoers file in place. 4 commands, and the task is done. The permissions block. SGID plus sticky bit on a shared directory. Chmod-R 2775 sets SGID recursively. Chown-R dev sets the group. Then the default ACL so every new file inherits the permissions. 3 commands. Done. Beat the SE Linux block. The sequence you should memorize. cmanage f context to register the rule. Restore con-rfv to apply it. If there's an AVC denial you can't figure out, search audit to allow cmodule generates and installs a custom policy. The networking block. NMCLI connection add with all the options chained together. Then NMCLI connection up, one pipeline. The LVM block. PV create, VG create, LV create, mkfs.xfs, echo, greater than, etc. FSTAB, mount A, 6 commands in sequence, LVM task complete. Click Domain Focus Table. Use this for your final revision. Storage and essential tools together are 40% of the exam. They deserve the most practice time. Security NC Linux at 15%. NC Linux is across every other task too, because a misconfigured context will break a service even if every other setting is correct. Click the practice checklist. Work through every item until you can do each one from memory in under 5 minutes. The root password reset. Practice it on a VM until it is completely automatic. The Podman linger task. Run it until lodging tail enable linger is a reflex. The LVM extend. Do it 3 times in a row. Next, the mind map shows the complete RHCSA skill tree. 7 domains, all interconnected. SE Linux touches every other domain. Networking underpins services, SSH, and containers. Storage underlies everything you mount. Click 10 rules for exam day. 1. Time is precious. The exam is 3 hours with a lot of tasks. If you're stuck on one task for more than 10 minutes, note it and move on. Come back at the end. Click 2. Verify every single change. System CTL status, after starting a service. Mount grep mount point, after mounting. Id alice, after creating a user. The exam tests outcomes, not intention. If the service is down for any reason, you don't get the points. Click 3. Permanent plus, reload for every firewall change. Always both. Click 4. SE Linux is almost always the answer when a correctly configured service can't access a file. Check context first with LSZ. Run restorecon first, then investigate booleans. Click 5. Use blkid to get UUID. Append to FSTAB. Test with mount A. Never use device names in FSTAB. Click 6. Touch/auto relabel after the root password reset. Miss this and the system may fail to boot cleanly because of SE Linux context mismatches. Click 7. P flag on setcbool makes it persistent. Without it, the boolean resets on reboot, and your task fails after the exam system is rebooted to verify. Click 8. Login CTL enable linger for any rootless Podman service task. Miss this, and the container disappears after logout. Click 9. System CTL daemon reload after every unit file creation or edit. Systemd uses cached unit file data. Without a reload, it will run the old version. Click 10. Read every task word for word. The exam is precise. It will say, the user must be able to log in. That means, set the shell to /bin/bash, not /sbn/no-login. It will say, the setting must persist after reboot. That means permanent flags on everything. And that is the complete RHCSA study guide. Every domain, every command, the boot process, C Linux, LVM, Podman, it is all here. Now go practice. Build 2 VMs, break things, fix them. Run through that practice checklist until it is automatic. The RHCSA is a performance-based exam. Knowledge alone doesn't pass it. Repetition does. If this video helped, please like and subscribe for more Linux and DevOps content. Good luck on the exam. You've got this.